So it's Monday, and what surprises have we got today? Well, I did say to somebody about a Binatone Longranger 6. Yesterday, Mr. Chippy was sorting out a shelf in the workshop he uses. We're going to have the window replaced in the next few months, and so all the steel shelf units need to come out, be temporarily shoved in one of our sheds, and then they can change the windows. And something which had fallen down the back was one of these Binatone Longranger 6s. Now we did the Longranger 12. It's kind of bizarre. I mean, all 40 channels are in there somewhere. And what was this? 6 through to 11. What a bizarre choice. It gave channel 9 for the days when there was meaningful use of channel 9, but no 14 and no 19, you know, so a bit of a bizarre choice. I think these were $44.99 and the 12 channel was like 50 something. But why was there a price difference? Because there's absolutely no difference whatsoever. There's no cost difference in making it. It must be a perceived difference that channels cost more, when once you're on synthesized radios it doesn't cost any more, however many channels. Open is definitely that way. I'm just wondering if he's got a battery pack in there or not. I think we've managed to release it. We've either released it or broken it, one or the other. Oh, I've got a picture of one of our organs when it was before we took it out of the church. We've got Amstrad manual, and we've got our Maycom EM27 brand new in a box sample, the final version of the final version. And you know what? I've never got a broken one of these to work, ever. It's also appeared in the early days as the realistic TLC 2015, was it? So, unfortunately, all the ones we've ever bought in or have acquired second hand, they've all had gas poker soldering done to make them do something they're not supposed to do. And every one of them, to my mind, has been destroyed. And we've probably got another half dozen that I don't think there's anything I can do with them. So this is a brand new in a box one, and that will be a forthcoming attraction. I've never done anything with them. Hey! Managed to open it up. So these need to have a 10. They came with an 8, and that's fine if we're using throwaway batteries, which we will be. Otherwise you need to get a 10 cell, which are readily available and will fit that way. I've probably said before, I've seen these on eBay before now, and instead of having the proper battery holder, they've got what in the UK is called a PP3 9-volt battery clipped onto there. Then they show it on and go, hey, it lights up. I mean, what kind of range did they get on a PP3 9-volt battery when it's a 12-volt radio anyway? So that, I'll tell you what, we'll leave that off because it's going to stay off. This is today's set. This has had the kiss of death, because obviously somebody's broken the aerial and they've replaced it with an SO239. That's why we're doing this, because we've got somebody who's they've sent me a message and said, well, we've got one, a nice hand portable, but the telescopic aerial's broken. Well, you know, if you stick a rubber duck on there, I think you'll get 1/8 of the range. So express that as 12.5%. So if you're getting 14 miles on it before, you won't anymore. We'll get a rubber duck on there and we'll do a little bit of a test, but it's not the weather to do those kind of tests. So we'll do it as a radio, and I would think all they've done is wired the antenna socket up there on this. So these are swine to put back together. You've got to get all those plastic thingies in the right place. These work very well. They're underappreciated. You You don't actually need 40 channels unless it's your sole, unless you're a teenager and it's your sole CB radio and you're not allowed a base station aerial at home and you don't have a car because you're not old enough, in which case you might want 40 channels. But for adults, you're not normally talking handheld to handheld. Now I think that is spannered into that position. I think what we've got to do is to go out and get a spanner and we'll take it from there. So I'm hoping, I bought these off eBay and I knew they were butchered when I bought them. I think I paid £10 for the two. So it turns out to be a 90mm spanner that's required to do this. Oh, I don't like this, it's the whole thing's moving. Whatever the technique they've done here, we're going to have to sort it out. Right. So the problem here, this has been done wrongly. That's okay, so that's come off. It was soldered just to where the telescopic area would have been. But the snag there is, it goes through a loading coil. So that loading coil is now totally irrelevant if you're putting a normal rubber duck aerial on, because that rubber duck aerial is going to be something that's manufactured to work at the frequency we're using, whereas the telescopic aerial isn't. So in actual fact, they needed to connect it to the external antenna socket. So if you've got one of these, if you've got a walkie-talkie that doesn't have an external socket, then that coil's going to have to come out and it's going to have to go on the input side of the coil. Not on there. That was totally wrong. Now, have they wrecked this radio? Because, you know, the SWR is going to be well out. And that just wasn't soldered well enough, because it wasn't that gave way, it was there. So let's see whether so really it's dead easy. I mean, the way they've pushed this bit of wire on, I think we'd be better off using with a screened cable, to be honest, because that may affect the SWR. But that aside, because you're transmitting through the case, aren't you? So it needs a bit of coaxial cable to go from the external aerial socket simply to this SO239 they've introduced. So what we now need to do is to connect this up to the test equipment using the normal technique and see whether we can do a tune-up on it. Okay, so I've got it powered up. I've just put crocodile clips to the battery clip on this instance. I've managed to find one of our adapters, and we'll get that connected to the test equipment. The wonderful thing about these sets is they do at least have an extension speaker socket, and so when we come on to receive, we will be able to do the receive without having to take the board out, hopefully. So we'll plug that into there. Select picture in picture, and then you can see my power meter. So I don't know what we're going to do selecting channel wise. Let's go. What's letter C? Then we're in the middle of the band, aren't we? That's channel 8. So it's 27 67125. So I set the signal generator ready. So let's look at transmit. So does it transmit? I'll tell you what it does. But it's nowhere near where it should be on the frequency. This is absolutely bizarre. How can that be? I'll just waggle the switch in case some dodgy code's coming out because of that. It was that. 2767082, so it's just off frequency a bit. And let's see how many watts the radio is doing at full power, and the answer is 2. And I'm right in saying it's a 12-volt radio. I can look that up anyway. So the synthesizer IC is down here, and it's one of these sets with a multi-crystal arrangement, so you have to use a marker oscillator to set up the receive for the oscillator for that. So we're going to set up the transmit, and the transmit line is quite clearly just these here. So I better put my soldering iron on, because those wax things are going to need melting. So the first thing we're going to have to do is to set the 10.24 master oscillator. No, you can't do that, can you, on this? There's no reference. Okay, so the reference crystal is a bit like a Uniden chassis. You get what you're given, and it isn't adjustable. So we have to rely on adjusting the transmit and then the receive. So if that's... Wow, that crystal seems loose. That crystal is loose. We're going to have to take the printed circuit board out. But I'll see if we can tune the transmitter first. So it's going to be that one, CV1. No, it isn't. It's the loose one. So which is our transmit frequency? 2767125. So why is it loose? That's worrying. I'm going to take the board out, and what we'll do is we'll see whether it's the crystal loose. It could be coming apart. If it's physically the crystal that's coming out of its casing, we're going to have to strap a wire across and solder it to the next crystal to stop that wiggling around. So it turns out to be a dry joint on the transmit crystal. Oops, wrong one. So don't know whether we can see this on the screen. That's an absolutely wicked dry joint. So we'll solder that one up. I have gone over it with my fiberglass brush. You have to be very, very quick with crystals. Very easily damaged. And there's the door. So for another 2 screws I've taken the speaker out and I have put the whole case and the knobs in the dishwasher. I thought I may as well. So we'll see if we can carry on with a bit of tune-up while we're exposing this part of the radio. We have the deviation control here on this subboard. I wish you'd have put a hole through this part of the board so you could access it, but no, you have to take the printed circuit board out to do the deviation. So it would seem sensible that while we've got it in lots of bits like this, we ought to be doing the deviation, especially if I can find the right remote button on the remote. There we are. Switch it back on. So I think before we finish doing the transmitter, we'll do the deviation. So we'll put the microphone over our little oscillator. We're going to have to set for a different frequency to normal. Where's the transmit button? There. So we'll go back to there. And so now, wallow. That looks a bit high. I think we need to just back that off a bit. Yes, it's at full. Wallow. Wallow. Still a bit, still over the top. Wallow. 1, 2. That looks about right. If you look in old CB books for the American boom 1970s era of CB radio, you'll see a Royce American set, handheld, with the 4 switches, which that clearly originally was a piece kind of made for. It's funny how they've turned up with different guises. So whoever made this for, oh, it does say on it somewhere, Brainchild, it says on the board. You just see that down there, Brainchild. So we'll carry on with the tune-up, but I'll now have to have it this way on. No, that would be too awkward for my pressing buttons at the same time as adjusting things. Let's try and put it the right way on. So with it now, no, nothing's happening because our negative's off. There we go. So go back to transmit power. You see we're doing 2 watts. I'll just adjust that final one. Yeah, that's making a huge difference. I guessed it would. Let's just go through the others. These knock the spots off some of these new little models with the tiny little rubber ducks. Now I have to go over to a different range. There we are, 3.5 watts. Bit like a new mobile. Remember, this is only running on 12 volts. Now I don't want to pop this thing, but let's just see what happens when we put it up to 13.8. So we'll just advance the power supply to 13.8, which is not what it's supposed to be running on. It does 4.5 watts. Now, it'll probably do that for about 20 seconds and kill itself. But it just goes to show. Put it back to 12. 3.5 watts. So I've now got to determine, was it that coil that's the one? Yeah, I think that is the loading coil. So does that mean that that's another transmit one that I've overlooked? I do have a circuit for these, but it's hand drawn and it's a photocopy of a photocopy. Just see. No, it makes no effects with the transmit at all. So that's transmit done. So let's just see if it's still on frequency after all that messing with the crystal. It is 6712, well, 3, it's dropped slightly. I think as a safety measure I'm still going to strap across those 2 crystals. So just pause the video. Well, there was another doorbell while I was doing that strapping of those crystals across, which is always good practice. And it was the parcel force man with some roof rack bars for my van, which we're turning into a bit of a mobile radio shack. So we're on receive. You like the doorbell that goes through our tannoy system. So it's like being at a railway station. So it's the same module. Okay, so we've now got 2767125 on our signal generator. We better turn the squelch down. Now, that's a noisy volume control. It's a sealed type, so it's difficult to get anything into these. I'm going to hope that that rivet is open and goes all the way through. Anyway, what we'll do, we'll plug this into our extension speaker, which plugs into our test equipment. Turn the volume down. Switch the signal generator on. Oh, well, it certainly is receiving. That's 1 microvolt. So we'll start with doing the detector, which is going to be that one there. Or discriminator, depending what you want to call it. So that's spot on. And then we'll move over to the cyanide meter. And this is totally unaffected by volume. It's got AGC. So if I turn the volume to there, it says 12. And if I turn the volume to there, it still says 12. And that is actually doing 0.4 microvolts for 12 decibel cyanide, which is excellent. It actually has a crystal filter. See, who thinks the Binatone 6-channel great big walkie-talkie's got a crystal filter? Well, there you are. Still don't know what that does. I wonder if that's the 54 meg trap. I better put the spectrum analyzer on and just check that. I don't expect it's going to do anything on receive, but we'll just find out. No. So that's what I think it is. We'll turn that so we've got about 4 or 5 dB. It makes it easier to tune. That could be one of the... It doesn't look like it's the front end. It's about there. And that doesn't look to be front end either. So do that about there. There we go. Let's try again. See whether that's front end. Yeah. I'll tell you what, it's pretty well aligned on the receive. I say that's going to be the loading coil for the antenna. So that's, you would take that out and go the far side of that if we hadn't got an external aerial socket. So let's see what we're getting now for 12 dB. It's now 0.39. So yeah, it was spot on, wasn't it? For 10 dB, it's 0.35 microvolts, and for 20, I'll tell you what, it does do 20, and it does 20 at 0.95 microvolts. Very, very good. Squelch, I don't think has a. I don't think there's anything else. I don't think we have any more presets. See, 455 filter is the H type there, and then you've got the crystal filter for your 10.695. So I'll just go on to the spectrum analyzer, and we'll just see whether that affects the second harmonic. Just put in the frequency 27.67125. So I press transmit, we should have the fundamental showing, and just round the corner we should have the harmonic. So does that affect that harmonic? The answer is yes, it does. I'm not exactly bothered about interference on harmonics on a walkie-talkie that's going to be hardly ever touched, but just for the argument, let's put the marker on it. It's minus 56 dBA. Yeah, it's in spec. So that's what that final one is. Just touch that up with the soldering iron. Now here comes the clever bit. Is it on frequency? So we'll turn the tone off the FM signal generator, and we need to get out that Chinese thing we have here. So switch this on. I know it's got memory somehow. Frequency. So it's 10.69 5. So that should now be doing something. Now, I'm hoping you can hear that musical note, but it's spot on frequency. So if I adjust the trimmer, you'll hear it go off frequency. So you've got to null the musical note. See, that's off. And that's about as near as it's going to go. And just to tell you what that is, I've altered the signal generator, and I'll put that on this screen. (27.67143). So it's very, very slightly out, well within tolerance. So it should be 67125. I mean, the instrument errors, you know, can easily be that, so it's absolutely fine. So once again, we've used our little Chinese generator as a marker oscillator, which is why I bought it for 40 odd quid. I was going to make something, a little oscillator with a crystal in it, have the crystal made for 10.695. And you know what, it would cost me 30 odd quid for the crystal to have made, and then you've got to mess about building it into a box and all that. So it's a cheaper option to buy that sophisticated instrument from China than to make something on a bit of variaboard. Right, so we'll turn picture-in-picture off. I need to wait for the dishwasher. Looks like it works great. Then we'll mess about with, we're going to wire it in with a bit of coax to the back of this socket. That's the right way to do it. I say they've done it the wrong way, they'd have had a huge SWR. Okay, so the radio is now put back together, so now we are just concentrating on making up a fly lead to go from the external aerial socket in this case to the SO239 which was already fitted. What I've done is to file very well the outer shoulder of the connector. It's a bit the worse for wear and a bit corroded, one could say, and we're going to solder between the inner, and that's been well done, and the outer, and then that's going to go to the exposed bit of the external aero socket. As I said before, if you're presented with a radio that doesn't have an external aero socket, then you need to find the, in this case it's there, the loading coil, and either remove it and connect, or just connect to the input side of that. You're going to end up with a high SWR and a blown up transmitter. Now this is high quality stuff. We buy from RS Components for industrial use, and in fact we have it on our base station aerial here, and that base station aerial is one of those fiberglass 18-foot things, such as the Amtron and others. Somehow I need to unbraid this, and it's not easy to work with. So I'll pause the camera while I get on with that. So just quickly go back on record, and we'll just zoom in a bit on that. That's carefully soldered onto there with sleeving, and then onto the inner. I've also made sure that the adapter goes in and the pin of the adapter doesn't try and push the soldering out, so it's well within there. So we need enough wire so that will go back there to go up about there, because there's enough to snake slightly inside. You can do that on in this occasion. So we'll just cut that. We have two cutters here. We've got the rubbish cutters, which we'll use to cut the whole bit, and then we've got the posh cutters. Right, so that's the SO239 soldered on at the other end. And I think before we put this together, the sensible thing to do would be to plug this SO239 into our test equipment and make sure that we've still got 3 point something watts coming out. And we have. And no doubt we've got receive as well. We have. So now we'll try and put it together. There we are, we now have it complete. And we'll pop it back on power. And one final check that it's working into the instruments. And of course we haven't affected the original, I managed to knock the clip off, haven't affected the original external aerial socket either. Just check the power once again. Deviation. Wallow. 1, 2. Can't see any deviation. Where's that gone? 1, 2. Wallow. 1, 2. Right, so I've had to take the whole printed circuit board, take it apart, take the printed circuit board out all over again, because the microphone was positioned wrongly. And I put it back exactly where they'd put it, which was in the wrong position. There's a tiny, tiny little hole. Here's the speaker grill. Just there is a tiny little hole. It's less than a 1/16 of an inch. And what they'd done, they'd put the microphone right against a solid plastic, and I simply put it back where I took it from. But of course it wasn't over the hole, so you were talking into a plastic case, which was absolutely useless. The other thing was, on low power it's 150 milliwatts. We did just check that at the same time. There you go, 150 milliwatts. And on full power, what am I doing? And on full power it is 3.5 watts. So we've got it into this socket, which I've put. We haven't affected that in any way whatsoever. And what we'll now do is to put it on our aerial and see if anybody's on channel 5, 6, 7, 8, 9 or 10 or whatever it does. No, 6, 7, 8, 9, 10 and 11. And then we'll do an on-the-air test in the usual way. Now I'm going to do a field test with this. I think what we'll do the 12 channel one and the 6 channel one, because they're exactly the same radio but with less channels. There's no difference whatsoever. That one we did. Now the weather's not right for doing this yet. And I'll send Mr. Chippy out with both these sets. This will only be able to have a rubber duck, and then everybody will be able to see what a dismal performance it'll be with a rubber duck. But it'll be on a par with those modern sets, you know, like the Capo Panther, was it? And the, what was the other one? H100. They're all doing about 3 miles on their rubber ducks. And this will be, I would think, par for the course. But this is capable of considerable range with a telescopic error, and I say that's what we're going to prove later on. So we're on the aerial now. 5, 6, 7, 8, 9, 10. Well, that was good fun, wasn't it? So, doing on the air test, so that's the Binatone Longranger 6, and reinstating, but done properly, the only way to turn it from a scrap radio into a usable radio. And that's it. Thanks for watching.